All right, welcome back to the deep dive. Today we're going to be doing, well, I guess I should say we're going to be taking a deep dive into something that should have a lot of appeal for those of you out there with philosophical inclinations.
Absolutely. It's really a deep dive that gets to the heart of some pretty fundamental questions about logic and language.
Yeah, yeah. So we're going to be looking at self-reference and the paradoxes that come up when you start dealing with self-reference. Um, and it's one of those things that just kind of seems to get at the root of how we think and what the limits of logic might be.
Yeah, it really reveals those cracks in the foundation.
Okay. Well, before we get too far into it,
Yeah.
I should mention that most of the material that we're going to be covering is coming from the Stanford Encyclopedia of Philosophy's entry on self-reference and paradox.
Yeah.
So if you want to follow along at home, you can go check that out.
Yeah, that's a great resource for anyone who wants to delve even deeper into this stuff.
Right. So, okay, what is self-reference? I think a lot of people have probably heard of the classic example, which is the liar sentence. So, this sentence is false.
Yeah.
Right. So what is it about that sentence that makes it so interesting? And why do we say it's self-referential?
Well, because the sentence is referring to itself. It's making a claim about its own truth, its own status. And that's where things start to get really tricky. Because if it's true, then it must be false based on what it's saying. And if it's false, then it must be true. And so we have this kind of inescapable loop.
Yeah. And it seems like the liar sentence itself is almost like a kind of a cheat, like it's somehow bending the rules or something to create this impossible situation. But the interesting thing to me is that this idea of self-reference crops up in other areas too. Like in art, you've got things like, paintings that are of themselves.
Right, like Escher's work with those hands drawing each other.
Right. Yeah, yeah. Or even in literature, you can have a story that's about the telling of itself.
Absolutely. There's that kind of metafiction where the act of storytelling itself becomes part of the story.
Right. But the interesting thing for philosophers is that this idea of self-reference isn't just some kind of a curiosity. It's actually something that has really deep implications for logic and for how we understand the world.
Yeah, and for the way we construct our systems of knowledge, because these self-referential paradoxes, they really put pressure on those systems. And they expose those points of tension where our intuitions and our logical frameworks kind of break down.
Yeah. So paradoxes. What exactly is a paradox? I mean, it's more than just like a surprising statement or something, right?
Right. It's not just something that's counterintuitive or unexpected. A paradox is an argument that seems to be logically valid, where you start with premises that seem to be true, and you follow the rules of logic, and you arrive at a conclusion that is contradictory.
So it's like the logic itself is leading us astray somehow.
In a way, yes. And that's why it's so unsettling, because logic is supposed to be this bedrock of rationality, this tool that helps us make sense of the world. But when we encounter these paradoxes, it suggests that there might be something fundamentally flawed or incomplete in our understanding of logic itself.
Yeah. I mean, it really does make you question some of your most basic assumptions.
Exactly. And for a philosopher, that's extremely valuable, because by exposing these weaknesses in our thinking, these paradoxes can actually lead us to a deeper, more sophisticated understanding of logic and language and the nature of truth itself.
Right. So what we're going to do in this deep dive is basically try to unpack some of these paradoxes and see what they can tell us about those big questions. But like I said, we don't want to get too bogged down in all the technical details. We really want to focus on the philosophical implications. So let's start with a bit of historical context. I mentioned the liar sentence earlier, but that's not a new idea, right?
No, not at all. The liar paradox has been around for centuries. It's often attributed to a philosopher named Eubulides of Megara, who lived in the 4th century BC. And it's really fascinating to see how this ancient puzzle continues to be relevant and continues to challenge philosophers even today.
Yeah. So the liar paradox, that's an example of what's called a semantic paradox. I
Right.
mean, it's a paradox that arises from the meaning of words, right? In this case, the meaning of the word truth.
Exactly. And there are other semantic paradoxes as well that play with self-reference in different ways. Like there's Grelling's paradox. So a predicate is heterological if it doesn't apply to itself. So like long is heterological because long is not a long word, right? But the word short is not heterological because short is a short word. So the question is heterological itself heterological.
Right. And that's where you get into that same kind of loop, right?
Yeah.
Because if it is, then it isn't, and if it isn't, then it is.
Exactly. And it's all because of this self-referential aspect. The word is referring to itself, and that creates this inescapable contradiction.
Okay. Then there's Berry's paradox. This one always kind of blows my mind. So it's about defining numbers. Like imagine you have the phrase, the smallest number that can't be described in less than 100 words. So what's the problem with that?
Well, the problem is that the phrase itself describes that number in less than 100 words. So it creates this contradiction where the number can and cannot be described in that way at the same time. And it really highlights this tension between our ability to refer to things with language and the actual properties of those things.
Right. And then there's Richard's paradox, which gets into some pretty deep math, but I think you can still get the gist of it. So imagine you have a list of all the phrases that can define real numbers. And then you construct a new number by going down the list, and basically you change the digit at each position. So if the nth number in the list have a 1 in the nth position, then your new number will have a 0 there, and vice versa.
Right. And the paradox arises because that new number you've constructed should be definable by some phrase, right? But it can't be on the list because it differs from every number on the list at least one digit. So it's this kind of diagonalization argument where you're creating something that's outside of the system that you've set up.
Right. Okay, so those are some examples of semantic paradoxes.
Yeah.
But self-reference also causes problems in other areas, like in set theory. And I guess the most famous one there is Russell's paradox. And this one is just so simple, but so profound.
It really is. The basic idea is that you consider the set of all sets that are not members of themselves. So like, the set of all cats is not a member of itself because it's a set, not a cat. But the set of all things that are not cats, well, that would include the set itself. So the question is, does the set of all sets that are not members of themselves belong to itself?
Yeah. And as soon as you try to answer that question, you realize that you're trapped.
Right.
Because if it does belong to itself, then it shouldn't. And if it doesn't belong to itself, then it should.
Exactly. And it really throws a wrench into naive set theory because it shows that this seemingly straightforward idea of just, gathering things together into a set based on some property, that idea itself can lead to contradictions.
Right. And it's not just Russell's paradox. There's also Cantor's paradox, which has to do with the idea of a set of all sets. So Cantor showed that the set of all subsets of a set, the power set, is always bigger than the original set.
Right. And so if you have a set of all sets, then its power set should be bigger than it. But how can that be? The power set is just made up of subsets of the original set. So you get this contradiction where something is both bigger and smaller than itself at the same time.
Yeah, it's really mind-bending. And then there's even a more recent paradox called the hypergame paradox. You heard of this one?
Oh, yeah. It's a fun one. So imagine a game, like a board game or something, that's guaranteed to end after a finite number of moves. We call that a well-founded game. And now we define hypergame as a game where the first player chooses any well-founded game, and then the second player makes the first move in that chosen game. So the question is hypergame itself well-founded?
Right. And it seems like it should be. Right.
Yeah.
Because any game of hypergame is just one move longer than the well-founded game that was chosen.
Right. But if hypergame is well-founded, then the first player could choose hypergame itself, and then the second player would be in the same situation and could choose hypergame again, and so on. And so you could potentially have a game that never ends, which contradicts the idea that hypergame is well-founded.
Yeah. It's like the game is somehow able to refer to itself and create this infinite loop.
Exactly. And it shows that even when we're dealing with something as seemingly concrete as games, these self-referential paradoxes can still pop up.
Okay, so we've talked about paradoxes in semantics and in set theory. But these things also crop up when we start thinking about knowledge. And one of the classic ones here is the paradox of the knower.
Right. So the paradox of the knower starts with the sentence, "This sentence is not known by anyone." And if that sentence is true, then it means nobody knows it. But if nobody knows it, then it's true. And if it's true, then somebody must know it, which contradicts the idea that nobody knows it.
Yeah. So it's like this self-referential statement about knowledge creates this impossible situation.
It does, and it highlights the complex relationship between truth and knowledge, because in a way, knowledge is supposed to be about truth, right? But when you have these self-referential statements, it seems like the very act of knowing something can somehow affect its truth value.
Right. Okay, so we've seen all these different paradoxes, and what's really striking to me is that they all seem to have a similar kind of structure, right? Like there's this common thread running through them.
There is, and that's something that philosophers have been trying to pin down for a long time. Like, take Grelling's paradox and Russell's paradox. They seem to be about different things, but the way the contradiction arises is very similar. It's all about this idea of something that refers to itself in a negative way.
Right. Like heterological is defined as not applying to itself, and Russell's set is defined as containing all the sets that are not members of themselves.
Exactly. And Graham Priest, a philosopher who's done a lot of work on paradoxes, he came up with this idea called the enclosure schema, which is an attempt to formalize this common structure.
Okay.
And he argues that many of these paradoxes can be seen as instances of this schema, where you have a set and you have a property that defines it, and you have a function that can pick out an element from that set. And that element ends up being both inside and outside the set.
Right. And so the idea is that if you can understand the enclosure schema, you might be able to understand the root of all these paradoxes. But even if you don't buy into the idea that there's this one schema that captures everything, I think it's still pretty clear that there are some deep connections between these paradoxes.
Absolutely. And that's why studying them is so valuable, because it can give us insights into the very nature of logic and language and the limits of our conceptual frameworks.
Okay, so far we've mostly been talking about paradoxes that involve negation. But there are also paradoxes that arise from self-reference in the context of implication. And one of the most famous ones is Curry's paradox. So what's that one all about?
Well, Curry's paradox starts with a sentence like, if this sentence is true, then F, where F can be any statement at all. And the paradox arises because you can actually use that sentence to prove anything, including things that are obviously false. And it's all because of the way implication works in classical logic.
Right. So how does that work? Like how can you prove something that's false using this Curry sentence?
Well, let's assume the Curry sentence is true. If it's true, then by its own content, if it's true, then F is true. And since we assumed it's true, we can conclude that F is true. And it doesn't matter what F is, it could be anything. And even though there's no explicit negation in the sentence, the way implication works in classical logic, it's kind of like negation is hidden in there. So
Yeah.
you still get this self-referential loop that creates the paradox.
Okay, so Curry's paradox is weird, but it still seems to rely on that direct self-reference, right? Like it has the phrase, this sentence in it. But there are also paradoxes that can arise from indirect self-reference. And a classic example of this is the postcard paradox. So have you ever heard of that
Oh,
one?
yeah, it's a classic. So imagine a postcard with two sides, right? On one side it says, the sentence on the other side is true. And on the other side it says, the sentence on the other side is false. So neither sentence directly refers to itself, but they refer to each other. And that creates the paradox.
Right, because if the sentence on the first side is true, then the sentence on the second side must be true, which means the sentence on the first side must be false. And you get this endless loop again.
Exactly. And it shows that even when you don't have that direct self-reference, you can still get these paradoxes if you have this kind of circular chain of reference.
Okay. And then there's Yablow's paradox. This one is even weirder because it seems to create a paradox without any kind of self-reference at all, direct or indirect.
Wait.
So have you ever come across this one?
Oh, yeah, Yablow's paradox. It's a real head scratcher. So it involves an infinite sequence of sentences where each sentence says that all the sentences after it are false. So no sentence is actually referring to itself, but you still get this paradoxical situation.
Right, because if any sentence in the sequence is true, then all the sentences after it must be false. But that would include the sentence that says that all the sentences after it are false, which would make that sentence true, and so on. And so you get this contradiction where you can't have any of the sentences be true, but you also can't have all of them be false.
It's really a strange one, and it's led to a lot of debate among philosophers about whether it really is a paradox and whether it really does avoid self-reference altogether. Because some people argue that even though there's no direct or circular self-reference, there's still this kind of implicit self-reference in the way the sentences are structured.
Right. Okay, so we've seen all these different paradoxes, semantic ones, set theoretic ones, epistemic ones. And I think it's pretty clear that these things are more than just, logical curiosities. They actually have some pretty deep implications for how we understand the world.
They do. They really force us to question our most basic assumptions about things like truth and knowledge and the nature of sets.
Yeah. And it's almost like Like these paradoxes are kind of like cracks in the foundation of our understanding of reality.
They are, and it's up to philosophers to try to figure out whether those cracks are just, superficial blemishes or whether they represent some deeper flaw in the foundation itself.
Right. Okay, so what do we do about these paradoxes? I mean, can we even solve them, or are we just stuck with them?
Well, that's a big question, and there's no easy answer, but philosophers and logicians have come up with a lot of different approaches to try to deal with these paradoxes. And one common strategy is to try to weaken some of the assumptions that lead to the paradoxes in the first place.
Right. Like maybe there's some assumption that we're making that seems totally obvious, but that's actually what's causing the problem.
Exactly. But the challenge is figuring out which assumption to give up. Because a lot of these assumptions are very deeply ingrained in the way we think.
Right. So what are some of the specific approaches that people have taken?
Well, one approach is to try to build hierarchies. Like Russell himself, after discovering his paradox, he came up with this idea called the theory of types. And the basic idea is that you divide all the things in the universe into different levels or types. And you say that a set can only contain things that are of a lower type than itself.
Right. So that way you prevent a set from being a member of itself. This is what was causing the problem in Russell's paradox.
Exactly. And similar ideas have been applied in other areas too. Like Tarski, he proposed a hierarchy of languages where you have a base language that talks about the world and then a meta language that talks about the base language and so on. And the idea is that each language can only have a truth predicate that applies to sentences in the languages below it. So you can't have a sentence that says this sentence is false within a single language.
Right. And then there are also epistemic hierarchies where you might have different levels of knowledge. So you might have knowledge about the world and then knowledge about your knowledge and so on. But these hierarchical approaches, they kind of feel a bit ad hoc, don't they? Like you're just imposing these artificial levels to avoid the paradoxes.
They do. And they've been criticized for that because it seems like, in the real world, we don't always talk or think in these strictly hierarchical ways. And there are some examples, like Saul Kripke's Nixon and Jones example, where it seems like you can have perfectly meaningful statements that involve indirect self-reference, but that would be ruled out by these hierarchical systems.
Right. Okay. So maybe hierarchies aren't the best solution. What else is there?
Well, another approach is to try to build what are called implicit hierarchies. And the idea here is that you don't have these explicit levels, but the hierarchy is somehow built into the way the system works.
Okay. So can you give me an example of that?
Yeah. So Kripke's theory of truth is a good example of this. So Kripke uses a three-valued logic where sentences can be true, false, or undefined. And he builds up a truth predicate in stages. And at each stage, he adds more sentences to the extension of the truth predicate, which are the sentences that are considered true. And he also adds more sentences to the anti-extension, which are the sentences that are considered false. And he keeps doing this until he reaches a point where nothing changes anymore.
Okay. So how does that help with the paradoxes?
Well, the liar sentence, for example, ends up being undefined in Kripke's system, so it's not true and it's not false. It's just kind of in this limbo state, and that way you avoid the contradiction.
Right. But even Kripke's theory has its problems, right?
It does, because you can still formulate strengthened liar sentences that seem to reintroduce the paradox. And also, Kripke's theory is kind of weak in terms of what it can express. Like, you can't even say within the theory that the liar sentence is undefined.
Right. Okay. So what else is there?
Well, there are other theories that try to deal with the paradoxes by modifying the logic itself. So there are paraconsistent logics, which allow contradictions to be true, and there are paracomplete logics, which allow sentences to be neither true nor false. And there are also substructural logics, which reject some of the basic principles of classical logic, like the law of excluded middle or the law of non-contradiction.
Okay. So those are some pretty radical approaches, right?
Yeah.
I mean, they're really changing the very foundations of logic.
They are, but that might be what's needed to really deal with these paradoxes in a satisfactory way. And there's also a lot of work being done on trying to understand self-reference itself better, like trying to come up with a more precise definition of what it means for something to refer to itself, and also trying to understand the role of things like Gödel numbering, which is a way of encoding sentences as numbers.
Right. Okay. So it seems like there's a lot of different approaches to dealing with these paradoxes, but is there any kind of consensus on what the best approach is?
Not really. It's still a very active area of research, and different philosophers have different views on what the best way forward is.
Okay. Well, I guess that's philosophy for you, right? Always more questions than answers.
That's right. But that's what makes it so interesting.
Right. Okay. So we've talked about the paradoxes themselves, and we've talked about some of the ways that philosophers have tried to deal with them. But why does any of this matter? I mean, why should we care about these abstract logical puzzles?
Well, for one thing, they have real consequences for other areas of knowledge and inquiry, like the liar paradox. It's not just a fun little brain teaser. It actually has implications for how we understand the concept of truth in philosophy and in logic.
Right. And Russell's paradox, that had a huge impact on the foundations of mathematics.
Exactly, because it showed that this naive idea of sets, that you could just define a set based on any property you wanted, that was actually inconsistent. And that led to the development of axiomatic set theory, which is a much more rigorous foundation for mathematics.
Right. And then there's Gödel's incompleteness theorems, which are some of the most profound results in the history of logic.
Yeah.
And those theorems actually have connections to these paradoxes of self-reference.
They do. Because Gödel's theorems show that there are limits to what we can prove within any given formal system. And the way he proved those theorems was by using a kind of self-referential construction to create a sentence that says this sentence is unprovable. And so you get this similar kind of situation where you have a sentence that's referring to itself in a way that creates a contradiction or a limitation on what the system can do.
Right. And then in computer science, there's the halting problem,
Hmm.
which is the problem of determining whether a given program will eventually halt or run forever. And it turns out that problem is undecidable, which means that there's no algorithm that can solve it for all possible programs.
Yeah.
And the proof of that undecidability actually uses a diagonalization argument that's very similar to the argument used in Richter's paradox.
It is. And so you see that these ideas of self-reference and paradox, they pop up in all these different areas. And they really highlight the interconnectedness of different fields of knowledge. And they also show that there are these deep, deep limits to what we can know and what we can do.
Right. Okay. So it's clear that these paradoxes have real implications for a lot of different areas. But
Yeah.
but I guess for me the most interesting thing about them is that they really make you think about the nature of thought itself.
They do, because it seems like our ability to think about ourselves, to reflect on our own thoughts, that's somehow tied up with the possibility of paradox. And so it makes you wonder whether paradox is just an unavoidable feature of any sufficiently complex system of thought.
Yeah. And it makes you wonder what those paradoxes might be telling us about the nature of reality, about the limits of what we can know.
Exactly. And so even though these paradoxes can be frustrating and can make your head spin, I think they're also incredibly valuable because
Mm,
they force us to confront these really deep questions about who we are and what it means to think and to understand.
right. And on that note, I guess we'll leave it there for today. But hopefully this deep dive has given you a little taste of the strangeness and the wonder of self-reference and paradox, and maybe it's even inspired you to go and do some more exploring on your own.
Absolutely. There's so much more to discover in this fascinating realm of logic and language. And who knows what other paradoxes are lurking out there, just waiting to be found.
Right. All right. Well, until next time, happy pondering.
And keep those philosophical wheels turning.